Euler's Identity. Before I get into Euler's Identity, which is e to the pi I plus 1 equals 0, I'm going to explain what each of those parts are. We're going to start off with e. E is a number, approximately 2.718. It's irrational, so I can't write it all. But there is a more exact formula way of writing it, and that is 1 plus 1 over x, and all that to the xth power. Now, as x gets higher and higher, or approaches infinity, the number approaches 2.718. Again, it's irrational, so it just keeps on going. Now, what's special about e is its own derivative. And you may remember derivatives. I made a video about it. So, when you find the derivative of e, it is itself. Next, we have pi. No, not that. That. Pi, you guys are probably familiar with, is also irrational, like e, and it is approximately 3.14. Now, pi is the ratio of the circumference of a circle to the diameter. C over d. So, no matter what the circumference or the diameter is, the ratio will be approximately 3.14, or pi. Now we have I, which is also a number, and this will be the last of our letters, which are actually numbers. And I'm going to talk about exponents for a sec. So, say we have 1 squared. Now, you know, 1 squared would be the same as 1 times 1, which is 1. Say we have, like, negative 1 times negative 1. That is also 1, because a negative times a negative is a positive. Now, because of this, you cannot square root, which is the opposite of a square. I made a video about them, so you can click there. You cannot square root a negative number, because you can't, whatever you square, you cannot get a negative number, because any negative number times itself would get you a positive number. So, since you can't have a negative square root, they came up with I, so you can have it. So, the square root of negative 1 is I. And they created this because now, when you get no solutions in a quadratic formula, you in fact do have solutions, 2 of them. They're just imaginary. Now we have the simplest number of them all, 1. And you guys should know what 1 is. It's 1 unit or something. Like, I'm holding 1 dry erase marker. I have 1 whiteboard. I have 1 camera. I mean, you guys should know what 1 is. If you don't, then how did you even get to the video? That's actually a more important question. Now we have a slightly harder to understand concept. 0. Still not hard to understand. And 0 is simply the absence of anything. So if you have 0, you don't have it. Like, you have $0 in your bank account. Just an example, I don't know how much money you have in your bank account. Now, you guys are probably wondering, well, how do we know that e to the pi I plus 1 equals 0? I mean, as far as we know, some mathematicians threw some random numbers together and decided they equal each other. Well, to prove that, we have e to the xi, and that equals the cosine of x plus the imaginary sine of x. Now, with that accepted, we can then continue on from there. We are going to plug in pi for x. So we have e to the pi I equals the cosine of pi plus the imaginary sine of pi. Now, at this point, it is important that you watch my trigonometry video, so I'm going to pause and let you watch that. Pause the video, by the way, so because I'm not going to pause the full length of that video. Alright, I'm going to assume that you've watched it, or that you remember it, or that you don't care enough to watch it. Either way, I'm moving on. So, if you remember the unit circle is 1 unit in radius, which means the diameter is 2 units, which means the circumference is 2 pi. So, half the way around, or half the circumference would be pi, which would be halfway around the circle. And at that point, that would be the coordinates -1, 0. And since cosine is x, that would give us -1 for cosine, plus 0 for sine, and 0 times I is 0. Anything times 0 is 0. So, we can add the 1 to that other side, which gives us e to the pi I plus 1 equals 0. And that is how we know it is accurate. But yeah, hope you enjoyed it, hope you learned something, and see ya!